Hello, in this chapter atom, we discuss Rutherford experiment. Sometimes it is called Geiger and Marsden experiment, or sometimes scattering of alpha particle. Here we have taken the radioactive source of alpha particle, maybe polonium, radium, or bismuth, anyone, because alpha particles are continuously coming out from the radioactive substance like this. This radioactive substance is trapped inside the lead box and beams of alpha particles are coming out which directed towards the gold foil by the collimator. So these are the beams of alpha particles coming towards the gold foil of thickness is very small, 2 into 10 to the power minus 7 meter, approximately 10 to the power minus 8 meter. And these alpha particles are scattered by the gold nucleus here of positive charge. The nucleus Ze in gold, that is 79 positive charge. So alpha particles is positive to E charge is repelled by this gold nucleus and is scattered in different directions. They are creating the fluorescence effect. Zinc sulfide screen can be observed by the sensitive microscope detector. It is rotating in 360-degree direction. So stream of alpha particles are that is be controlled by the collimator in one direction. Now scattered particle can be viewed by the rotatory detector or microscope. Zinc sulfide screen is used to observe the alpha particle. This whole arrangement is kept in the vacuum chamber. Now here the central line alpha particle, say number 1 stream, is coming towards the gold nucleus, repelled by the positive charge, and is coming closer and closer, and the closest distance, that is R0, and rebounding back, bouncing back, traversing the same direction, coming back. And like stream 2 is deviated by an angle, say theta scattering angle, maybe 150 and 60 degree. Like stream 3 is deviated by approximately 90 degree, stream 4 is deviated by say 30-40 degree, and stream 5 is almost deviated coming this direction. Because this distance is quite large in comparison, so they are going undeviated without any deflection. Similarly, 2 dash, 3 dash, 4 dash, and 5 dash in opposite direction. Now we are discussing impact parameter B. It is defined as the perpendicular distance between the velocity vector of alpha particle when it is at a far off distance from the gold foil from the central line. This is the central line 1. The formula of impact parameter B is given by 1 upon 4 pi epsilon naught Z E square cot theta by 2 upon kinetic energy half mv square, where theta is the scattering angle. This derivation is out of course, out of syllabus in CBSE. So you have to learn only the formula. When we increase say B0, means this alpha particle is moving along the central line. This impact parameter B0, then the scattering angle is 180 degree going towards the gold foil and bouncing back. When beta B, when B is increasing, scattering angle theta decreasing from 180 degree to 150, 90, 30, 10 and 0. When B is sufficiently large from the central line, impact parameter is large, then theta is approximately 0, means alpha particle stream are moving without any deflection. When here this number of alpha particles is scattered, this n theta is directly proportional to 1 upon sine theta by 2 over 4, where theta is the scattering angle. When theta is 0 degree, central line, this is the deviation moving toward the gold foil, and from here it is bouncing back. So this is the distance R0 called distance of closest approach. Here at R0 distance, the particle comes to rest momentarily and then bouncing back. We can easily find out R0 the distance of closest approach. But here this is the graph between the deflected scattered alpha particles versus scattering angle theta. From this graph or observation, we can say here roughly 1 crore 10 to the power 7 alpha particles are moving almost without deviation, and roughly 4,000 to 8,000 reflected approximately by an angle 90 degree, and very few 6 to 8 only cutting angle is 180 degree, means they are coming toward the central line and bouncing back. So here we are deriving the expressions of distance of closest approach by the conservation law of energy. Potential energy and the kinetic energy when the alpha particle is far off distance, potential energy and the kinetic energy at a distance of closest approach from the gold nucleus. It is far off distance or is large, quite large, then potential energy is approximately zero. And this is the kinetic energy of the particle when it is at a far off distance. Potential energy at the distance of closest approach, formula is K Q1 Q2 upon R. K means 1 upon 4 pi epsilon naught. This is the charge on nucleus. 2e, this is the charge of alpha particle, and R naught is the distance of closest approach. By cross multiplication, this is the formula coming here. Distance of closest approach is 1 upon 4 pi epsilon naught 2z e square upon half mv square kinetic energy. This is the formula of distance of closest approach. Suppose in the experiment by the Rutherford, they have taken the kinetic energy of mv square of alpha particle is roughly 5.5 million electron volt. Then by calculation R naught found here 45 Fermi, 45 into 10 power minus 15 meter. They have increased the energy from 5.5 to 7.7 million electron volt. Then this is the distance of closest approach, that is 30 Fermi, and radius of gold nucleus here is less than 30 Fermi. तो यहाँ पे हिट नहीं किया. फ्लैट अगर ज्यादा लेंगे तो क्या हो जाएगा, हिट करेगा. हमें हिट नहीं करना है गोल्ड न्यूक्लियस को अल्फा पार्टिकल से, हिट नहीं करना, ब्रेक नहीं करना, पास लेना है कि बिकॉज वी आर इंटरेस्टेड हियर टू फाइंड आउट द size of the nucleus. We don't want to hit it. So this is approximately the maximum energy and closure distance. So this is the approximate idea radius of the gold nucleus here. Here on observation from the graph we can see here observations. Number 1, most of the alpha particles are passing straight without deviations to the solenoid to the solid. And deflection is almost very less or no deflection when B is impact parameter is very large. And very few alpha particles, they are 4,000 to 8,000 roughly, suffering the angle by 90 degree. Scattering angle roughly approximately 90 degree, and very few roughly 6 to 8 only particle scattering angle is theta 180 degree bouncing back. So this is the result of experiment here. All the mass lie inside the nucleus, neutrons and protons, in very tiny space that is called nucleus. So matter is empty because all the particle is passing without deviation, and second, all the positive charge lying inside the nucleus, and size of nucleus is very small, Fermi level. Here the ratio of size of the atom upon size of the nucleus is 1 angstrom level, and size of the nucleus is Fermi level. So we are getting this ratio 10 to the power 5. It means size of atom is roughly 10 to the power 5 times larger than the size of the nucleus. Now failure of Rutherford model. They have succeeded to find out the size of the nucleus. Very good, very good. But here regarding the electron, as per the Rutherford, electron due to the attraction force with the nucleus positive charge, they are coming closer and finally fell down in the nucleus. Not correct. Secondly, as the electron as per the Rutherford model, they are coming closer and closer like this and emitting the energy and finally fall in the nucleus, which is not possible because losing energy, continuously radiating energy, emitting energy continuously, so we must get the continuous emission spectrum. But practically we are finding the disc emission spectrum. So this is also wrong. So there are two reasons here why we take the Rutherford model as a failure model. Now the electrons revolution around the nucleus is very well suggested by the Bohr's theory. The Bohr theory for the stationary or stable orbit the hydrogen atom. Is the hydrogen nucleus, only proton is there, and on which then electrons are revolving discrete and fixed orbits. That is the electron revolving around the nucleus, different orbits. Say this is the radius here r. As per Bohr's theory, orbits will be stable, stationary if the attraction force must be equal to the centrifugal force. They are equal and opposite. So attraction force is equal to centrifugal force. This is the equation 1. Now second postulates are given by the Bohr is for the stationary orbit, stable orbit, angular momentum must be integral multiple of this quantity h upon 2 pi, where h is the Planck constant. The numerical value of Planck constant is 6.16 10 power minus 34. R is the radius of the orbit, and here n must be integer. And third postulate or suggestion: if electron is jumping from inner orbit to the outer orbit, is possible by absorbing the energy by the electron or gaining the energy. It is called absorption spectrum. And electron is jumping from outer orbit to inner orbit in terms of the photons. Spectrum is called emission spectrum, where change in energy is given by final minus initial. Now from the equation 1, attraction force is the centrifugal force. Here, this is the formula here from equation 1, attraction force equals centrifugal. R cancel out, then mv square upon r cancel हो गया, तो 2 से divide कर दिया दोनों तरफ. Half mv square is the kinetic energy. So kinetic energy is given by this formula here. So this is the formula of kinetic energy, 1 upon 4 pi epsilon naught E square upon 2r. Whereas potential energy formula is k q1 q2 upon r. So this is the formula of potential energy. Total energy is the sum of potential plus kinetic. We are getting this. So this is the kinetic energy given by equation 1, potential energy given by equation 2, and the total energy given by equation 3. From these three equations, we say here kinetic energy is positive, total energy and potential energy is negative. So we are taking the magnitude. Numerical value of kinetic energy and total energy is same. It is the half of the potential energy in magnitude only. Because total energy and potential energy are. Now, Bohr's theory for the stationary or stable orbit for any atom, not the hydrogen atom. Hydrogen atom Z is equal to 1, but we are taking any atom here. So, first postulate given by the Bohr's theory regarding the stable or stationary orbit, attraction force must be equal force. अट्रैक्शन फोर्स में यहाँ पे जेड भी आएगा, क्योंकि यहाँ पे न्यूक्लियस में पॉजिटिव चार्ज कितना होगा, जेड ही, इलेक्ट्रॉन का चार्ज तो ही है. तो दिस attraction force is equal to centrifugal. And second postulate here, angular momentum L is equal to mvr is equal to n into h upon 2 pi and must be integer. Again, energy difference final minus initial means inner orbit to outer orbit, absorption is spectrum, and outer to inner, this is emission spectrum. Here electrons are excited from inner to outer by consuming the absorbing the energy. There remains for very small time, that is called excitation time, only 10 to power minus 8 seconds. After that it comes to lower orbit by emitting the photons. The excitation time is very less, of the order of 10 to power minus 8 seconds only. Now deriving the expressions of radius, speed, kinetic energy, potential energy, total energy, etc. from equation 2 here, L is equal to mvr is equal to nh upon 2 pi. So here from this equation V equal to nh upon 2 pi, m and r which are here and 4. So this is the expression of speed of the electron in the orbit. Now putting this value of V in equation 1 here, is the equation 1. So 1 upon 4 pi epsilon naught z square upon r square m upon r v square. V की वैल्यू हमने ये पुट कर दी, स्क्वायर कर दी, एंड सॉल्व करके 4 कैंसिल, 5 कैंसिल, एम भी कैंसिल हो जाएगा. तो आर orbit of the radius of the orbit is given by r is equal to n square epsilon naught h square upon pi m z e square, given by equation 5. From 5, this quantity inside the bracket, that is constant quantity, so r is directly proportional to n square. The ratio of radius 1, 2, 3, 4, etc. is given by 1, 4, 9, 16, 25 ratio. Putting all the values inside the bracket here, like in this equation 5, we are putting the values of these quantities in at the bracket. So here R equal to n square 8.85 10 power minus 12, H 6.63 10 power minus 34 square, Pi 3.14, M mass of electron 9.1 10 1, E charge of electron 1.6 10 power minus 19, and Z is equal to 1 for hydrogen atom. We are solving here all the values that comes here 0.529 angstrom, roughly 0.53 angstrom. So this is the radius of first orbit hydrogen atom, that is 0.53 angstrom, and is integer. So here we put the value of R in equation 4 to find the speed of the electron, orbiting electron. Here putting the values here. So after solving, we are getting the speed of electron in particular orbit n given by this. You put the value of Z is equal to 1 for hydrogen atom, all the values putting, and we are getting V is equal to 1 upon n, 2.2 into 10 power 6 meter per second, or C upon 137, where C is the speed of, here V is inversely proportional to by n, 1 by n, inversely proportional to n or directly proportional to 1 by n. N increases, V decreases, and here n increases, radius increases, n square times, say kinetic energy given by half mv square, putting the value of V, formula here this given by equation 6 पुट कर देंगे तो हमको मिलेगी kinetic energy. ये हो गया kinetic energy का formula given by equation 7. And potential energy K Q1 Q2 1 R, K Q1 means ZE हो जाएगा गोल्ड न्यूक्लियस का, एंड इलेक्ट्रॉन हियर इज, और कोई भी ले सकते हैं, जेड अभी वैल्यू हमने असाइन नहीं किया है, any value ZE, and minus E for electron, putting the value of R here. Then this is the formula of potential energy, negative 1 upon n square and Z square equals 4 upon 4 epsilon naught square H. The sum of kinetic and potential energy is the total energy, and given by equation 9. So from 7 kinetic energy, potential energy, equation 9 total energy, we see kinetic energy equal to numerical value of total energy and half of the potential energy numerical value. So here kinetic energy is equal to what? Modulus of total energy is equal to half of modulus of potential energy. The same relation here also, like this given by equation 4 here. Now very importantly, discussing the energy total energy here, putting the values in equation 9 here. All the values, mass of electron, Z is equal to 1 for hydrogen atom, E electronic charge, and epsilon value H. After solving, it is coming here, the total energy is minus 13.6 upon n square electron volt. We have converted joule to electron volt. Say n is equal to 1 means first orbit total energy, n is equal to 2 means 4 से डिवाइड किया तो ये हो जाएगी सेकेंड ऑर्बिट की एनर्जी, थर्ड ऑर्बिट एनर्जी, fourth orbit energy, fifth orbit energy, like so. Suppose here it is negative minus 13.6 for first orbit. अगर हम इतनी एनर्जी पॉजिटिव दे दें, देन फ्री हो गया, आयनाइज हो गया, इलेक्ट्रॉन बाहर आ गया तो आयनाइज हो गया. नहीं अगर पॉजिटिव देते हैं तो ये कहलाएगी पोटेंशियल आयनाइजेशन एनर्जी. आयनाइजेशन एनर्जी 13.6 फॉर फर्स्ट ऑर्बिट, फॉर सेकेंड ऑर्बिट पॉजिटिव 3.4 इलेक्ट्रॉन वोल्ट, थर्ड ऑर्बिट नहीं पॉजिटिव देना है, फोर्थ ऑर्बिट ले. अगर हम पोटेंशियल देते हैं तो 13.6 वोल्टेज आयनाइजेशन पोटेंशियल हो जाएगा, सेकेंड ऑर्बिट का हो जाएगा प्लस का 3.4 वोल्ट आयनाइजेशन पोटेंशियल, आयनाइजेशन एनर्जी. सिमिलरली फॉर ऑल द ऑर्बिट्स, जितनी नेगेटिव उतनी पॉजिटिव देनी पड़ेगी, सो इट विल बी फ्रीड आयनाइजेशन एनर्जी, या वोल्टेज मिलेंगे तो आयनाइजेशन वोल्टेज. यूजिंग इक्वेशन 9 फॉर दिस टोटल एनर्जी अगेन. Now transition of electron from inner to outer to inner. Here we have discussed earlier also, electron jumping from inner to outer, it is absorbing, outer to inner it is emitting. So emission spectrum. So as per the third postulates of Bohr's, delta E change in energy is final minus initial. एनर्जी का फॉर्मूला होगा h न्यू या h by lambda. C speed of light, h Planck constant, lambda is the wavelength of the wave emitted. So putting these values here, ये बाहर आ गया, ये 1 upon n I का स्क्वायर माइनस एन एफ स्क्वायर, माइनस की वजह से फाइनल माइनस इनिशियल हमको दिख रहा है, इनिशियल माइनस फाइनल माइनस की वजह से. तो अगर हम इसको सॉल्व करते हैं, इसको बोलेंगे रेडबर्ग कांस्टेंट R. न्यूमेरिकल वैल्यू क्या हो जाएगी इसकी 1.097 × 10⁻⁷ per meter. It's called Rydberg constant. यही फॉर्मूला कन्वर्ट हो गया इक्वेशन 11 में. 1/λ इसको बोल रहे हैं हम लोग वेव नंबर, इसी को बोलते हैं क्वांटिटी को वेव नंबर. गिवन बाई r Rydberg constant bracket 1/ni square minus nf square. So spectral series, if ni is equal to 1 and nf more than 1, 2, 3, 4, 5, 6 like, it is called the Lyman series. Comes here in the UV rays, ultraviolet rays. If ni is 2, nf is more than 2, 3, 4, 5, 6 like, it is called Bohr series. It is coming under visible spectrum. If ni is 3, called Parsons series, nf more than 3, 4, 5, 6 like, called Parsons series, it is infrared radiation. If ni is 4, nf is more than 4, 5, 6, 7 like, is called bracket series. Infrared radiations, ni is 5, nf is more than 5, 7, 8 like, it is called Pfund series. Infrared radiations, if ni is 6, nf is more than 6, called Humphrey series. Again it is in infrared radiation. We can see, looking by this figure here, one is involved and coming from second, third, fourth, fifth like, so it is called Lyman series. Up to second from anyone higher called Bohr, up to third from any series higher called Parsons series, like bracket series, like say Pfund series. Or in this figure also we can see here, say this first one is say n is equal to 1, from higher to 1 called Lyman series, 2 from higher Bohr series, from higher to 3 called Parsons series, bracket series, Pfund series like. And here n is equal to 1 minus 13.6, n is equal to 2, 3.4 minus third for minus 1.51, 5 finite का 0 हो जाएगा. We have seen here like this here. Given by equation is 10. Total energy is equal to minus 13.6 upon n square electron volt. N is equal to 1, 2, 3. Here, very important, very important here. A first line of series called the first member. For this line wavelength, this line wavelength is called a maximum and frequency is minimum, energy is also minimum. If we calculate here lambda maximum, suppose ni is equal to n, nf is 1 higher plus 1. So this is the formula of wavelength. N square, n plus 1 whole square, 2n plus 1 and r is called Rydberg constant. For example, Lyman series n is equal to 1. So ये 1 एक हायर हो जाएगा, nf हो जाएगा 2, लेस एनर्जी एंड मैक्सिमम वेवलेंथ. इसी फॉर्मूले से डायरेक्टली निकाल सकते हैं या उससे हम कैलकुलेट भी कर सकते हैं. डायरेक्टली निकाल लेंगे तो क्या हो जाएगा 1 स्क्वायर, ये 1 प्लस 1 2 स्क्वायर एंड 2n प्लस 1 से इसकी वैल्यू हो गई वेवलेंथ की टर्म में. ये मीटर था, हमने कन्वर्ट कर लिया इनटू एंगस्ट्रॉम. तो 1215.4 एंगस्ट्रॉम ये मैक्सिमम वेवलेंथ है. नियरेस्ट में जाएंगे, जैसे 1 में लाइमन से 1 से 2 में, बॉमर में 2 से 3 में. जब ब्रैकेट सीरीज देंगे 5 Pfund से 5 to 6 नियरेस्ट. तो बॉमर सीरीज n i इक्वल टू 2, nf एक ज्यादा हो जाएगा 3. से सॉल्व करके ये आ रहा 656.3 एंड लास्ट लिमिट मीन्स अप टू इन्फिनिटी इट इज कॉल्ड दी सीरीज लिमिट. यानी हम अगर बात करते हैं फ्रीक्वेंसी मैक्सिमम हो जाएगी, एनर्जी मैक्सिमम, लेकिन वेवलेंथ मिनिमम. मिनिमम वेवलेंथ के लिए करेंगे तो एन आई अगर n है तो n2 इनफाइनाइट हो जाएगा सीरीज लिमिट के. फॉर्मूला क्या हो जाएगा इसका, लैम्डा मिनिमम इक्वल टू n स्क्वायर अपॉन r. r इज द Rydberg कांस्टेंट. रेशियो लेंगे फर्स्ट मेंबर टू दिस सीरीज लिमिट, तो ये रेशियो आ जाएगा लैम्डा मैक्सिमम अपन मिनिमम n प्लस 1 होल स्क्वायर अपन 2n प्लस 1. फॉर डिफरेंट स्पेक्ट्रल सीरीज परचेस लाइमन, Bohr, Parsons series, bracket and Pfund series, the transition n is equal to 1, ni 1 है, n 1 से ज़्यादा, तो लैम्डा मैक्सिमम इतना होगा, मिनिमम ये होगा, इसका रेशियो हो जाएगा 4/3. अल्ट्रावायलेट रीजन में आता है. Bohr सीरीज n इज 2 है, इससे ज़्यादा है तो मैक्सिमम वैल्यू ये और मिनिमम ये रेशियो हो जाएगा. फॉर्मूले से पहले भी देख सकते हैं, इस वाले फॉर्मूले से भी निकाल सकते हैं डायरेक्टली. सॉल्व करके ये आ रहा है 9/5 r टर्म्स ऑफ रेशियो देख रहे हैं. आर कैंसिल हो जाएगा विजिबल स्पेक्ट्रम में. सिमिलरली फॉर पार्सन सीरीज द रेशियो ब्रैकेट सीरीज एंड सीरीज ऑल आर इन रेड. फर्स्ट वन लाइमन सीरीज इन अल्ट्रावायलेट रीजन, सेकंड Bohr सीरीज फॉर विजिबल रीजन. नाउ de-Brougli given the statement for the fixed stable orbit differently than the postulates given by the Bohr theory, but ultimately both are same. As per the de-Brougli explanation for the stable orbit, according to de-Brougli, for stable orbit, number of waves in any stable orbit must be integral or quantized associated with the revolving electron. यहाँ पे देख रहे हो जितनी भी वेवलेंथ है ये नंबर इंटीजर में आनी चाहिए, फ्रैक्शन में पॉसिबल नहीं है, और फ्रैक्शन में होगा तो स्टेबल ऑर्बिट नहीं। तो एज पर द de-Brougli, is the distance to pi r perimeter is equal to n lambda. N must be integer, and we know the de-Brougli wavelength formula, lambda is equal to h upon mv। और इसको पुट करते हैं लैम्डा की जगह h upon mv, क्रॉस मल्टीप्लाई करते हैं mv r, 2 पाई नीचे आ गया, ये सीधा सीधा मिल गया, l इज इक्वल टू mv r इज इक्वल टू n h upon 2 पाई। ये फॉर्मूला किसका था? दिस इज द फॉर्मूला गिवन बाय द बोर्स सेकंड पोस्टुलेट। दिस इज द बोर्स सेकंड पोस्टुलेट। तो मतलब ये हो गया कि जो बोर्स बोल रहे हैं और de-Brougli बोल रहे हैं, दोनों एक ही बात को कह रहे हैं, लेकिन अपने अपने दोनों का मतलब एक ही है। Either you say according to de-Brougli number of waves in stable orbit must be integer, or by the Bohr's second postulate angular momentum equal to h upon 2 pi का इंटीग्रल मल्टीपल n must be integer अपन नंबर ऑफ वेव्स इंटीग्रल। दोनों एक ही बात ही अपने अपने तरीके हैं कहने के, बोल रहे हैं दोनों स्टेबल ऑर्बिट के लिए, दोनों अल्टीमेटली एक बात।